So here, what we are trying to do here is I just give a brush up on what we covered in the week one. So it is only one class completed. See what we discuss about. We want to know that why I have to do this particular course, right? And why that is very important for me. That's the main reason what we are trying to connect with the people and then we are connecting to do. See, the point is we are trying to incorporate and then trying to give the context to the why I need to learn my Lean Six Sigma. Right. So the why is we should be very clear. See, what we are trying to accommodate here is we are going to the lot of automation. Okay, we are going through a lot of AI and ML, right? And we should be able to run that particular show, right? Currently, we are handling a people. It may go back to the agentic AI, right? How I can see my process in a different way. That's what the process has started. That's what we are discussing in the training course, right? So first week we covered on the basics of the Lean Six Sigma. So this week also we'll go in the same order. We are going to see some of the historical event, what happened, how they are doing it. And whatever we covered in the last week, very important portion is you should know what is your defect rate by the Lean Six Sigma level, right? One Sigma, it talks about 6,90,000 error. When it is coming to Six Sigma, it is 3.4. So today also we asked some question, right? How the Air Force or air transport, what is their Sigma level, right? We are not seeing any of the major accidents, right? They will be around 7 to 8 or even more than that Sigma level, right? That's what their operation model, right? And that's the way it's going on. And we are planning to, or we are trying to achieve the Six Sigma level, which is an optimum. And when you are processing Three Sigma level, what do you need to do? You have to revamp your process completely. You have to dismantle and then you have to set the process right. Okay, that is the one way you have to do that, right? And second one, what we covered is we are covered about the quality part, why we are calculating DPMO, and then what is the technique to reach there. These are all we covered last week. Okay, and who are all the quality pioneers who started this Lean Six Sigma? These are all the things we covered. So now coming to the part two, the second week. So we are going in depth in the theoretical part, right? See, the course alignment is we'll complete the theoretical part in the basic itself, and then when it is coming to DMAC, we will go inside the practical portion on the RCM side. That's what the alignment. See, now what we are going to learn here is the value of the Six Sigma is our core subject today, right? So we are going to see, right, what it aim at. See, the Six Sigma and then the Lean, it mainly aims at the customer satisfaction. Okay, when the customers get satisfied, when their expectation is met, right? It is going to focus on the customer and it is aimed to give a better value to the customer and by which you are going to get a profitable result, right? If you take RCM, right, what is your client requirement? Their revenue should be improved and outstanding AR should be collected. And for example, my date of services can be reduced for 2 days or 3 days. How quickly I can collect my revenue? That's what the client expectation, right? So how we are going to achieve it through this Lean Six Sigma. And implementation, what it is going to implement on the processes, identify the needs and expectations. See, to reach the client goal, what I have to do, how I am going to convert my client need into the CTQ, critical to quality. That's what the Lean Six Sigma focus on. And here the important topic is voice of the customer. Okay, this is a very important term in Six Sigma. When we talk about voice of the customer, it talks about what they need. It may be stated need or unstated need. We will go through in detail in due course. So here the VOC is going to talk about important feature and the benefits, quality and perceived by the customer. See, you think this what the client is expectation, but the client may expect differently. See, that's the reason whenever we get any new client, we will ask them, right, what is the metrics you want me to measure? What is the KPI metrics you want to check? That's the main reason we are getting that. Okay, you are perceived by the customer may be different, and what you are going to give it to the client may be different. So we want to align that, right? And we will focus on the client requirement and customize the product, service, add-on, and the features based on the voice of the customer. VOC collection method. See, we are fortunate enough to know the voice of customer very easily because when we sign the contract, right, it's very clear. Our goal is very simple. We have to improve our collection and we have to reduce our AR or we have to reduce our date of service. Okay, or from the current revenue pattern, I have to increase to up to 1.5% or 2%, or some client will, we will go up to 15% uplift of the revenue, right? So we are very clear. When it is coming to the general organization or general management, we don't know what is the client expectation. See, for example, you take a scenario of a customer focused product. Say, for example, I'm planning to release some new soap in the market. I don't know what is my client required, right? What is a customer requirement? It will go for focus group, and then it will go for a survey, and then it will go for indirect interviews, okay, to get the need of the people. Based on that, the market will release. But we are fortunate enough, we are very clear what our client need, and the VOC is very clear to us. It will not take tough time to understand the VOC, right? In the Six Sigma DMAC, we have in the define phase, we will focus on the VOC. That is a very, very crucial for the define phase. So as I told you, in all other management, identifying VOC is a bigger challenge, but we don't have that problem. We know very well what client is need and what is the voice of the customer, right? And the integrating the customer requirement into the design. This, say, for example, I don't know what the client need is. Then I'll go to the quality function deployment, which is called QFD. With if you go to the black belt, they will talk very detailed information about the QFD method, how to align, how to get it, okay, how we can bring that to the CTQ. Okay, the QFD is a planning tool which is going to give customer delight, want, need, and how we are going to get the technical requirements. See, customer may want N number. Am I able to produce that? Okay, that's called the technical functions. Okay, the QFD will connect all this, right? When the what customer want, right? See, I may need a soap. For that soap, I cannot get delight, right? So in that soap, what flavor or what specialty I should add it there? Okay, based on that, we are going to create this QFD function. And the next one is design for Six Sigma. This approach will give you the DMADV and then IDOV. Okay, these are all we are going to see detailed in the coming classes. And the next one is the continuous improvement and satisfaction. Okay, the Lean Six Sigma focus on, say, I'm giving some product or I'm giving some service to the client. Okay. After some time, client is not going to be satisfied unless I'm going to give a continuous improvement on it. See, today my customer requirement saying that my DSO should be lesser than 35 days. Okay. Tomorrow they will come back. Tomorrow, in the sense, for after 6 months, they may come back and say that you are still in 35 when I'm going to reach 30, right? The customer improvement or the customer expectation is going to evolve. Based on that, your process need to go for a continuous improvement, right? Unless you evolve into the customer or continuous improvement, you cannot survive in the competitive edge market, right? See, unless your competitor is going to give another 0.5% reduction in the collection, or for example, FTE, instead of $2,000, they are going to offer 1,900, the customer at any time can shift there, right? So here, if you show the continuous improvement in the process, then you will have a better competitive edge. Like you, right? Say, for example, you're going to the interview for your betterment or a career growth, right? When you add in your title, okay, I know black belt, I know Six Sigma, right? I know how to improve the process. That's going to be a competitive advantage, right? Compared to the your competitor on the same interview forum, right? That's what the competitive advantage is going to add for the client. So the main purpose is we will know what is client requirement, one, and based on the client requirement, I'm going to set my process in Lean Six Sigma. And I'm not going to stop there, right? I'm going to create in continuous improvement I'm going to bring so that I can make my client to delight stage, not only from the want stage, right? So the DMAC is a methodology, what we are going to use for this. It is a proper statistical tool, right? DMAC talks about define, measure, analyze, improve, and control, right? So here, as we know, 3.4 defects per million is our target, and 99.9997% of quality level, what we are trying to achieve. In that, the process performance metrics is everything based on DPMO. And when you are coming to the production side, right, even if you take your AR production or your billing production, rolled throughput yield, RTY is your measuring point. Okay, what is RTY? We have a detailed session with the practical in the course, right? We will cover it. And cost of the quality, you know very well, right? No quality will come free of cost. Every quality auditor need to be paid. Whatever your effort you are going to put it need cost on it. See, for example, in the general, okay, 25 to 40% of the annual revenue is taken by cost of quality. Unless you improve your quality, your cost to quality is going to be a major drain for your revenue, right? So improving one sigma level, it is going to improve your 10% of net income. See what it means. Currently, you are in 3 sigma level. And if you are going to move to the 4 sigma level, your net revenue can be improved by 10%, right? So how net income can be improved? I don't want this many people to handle it, right? Or my process is very quicker and I'm able to collect the revenue. That definitely is going to improve here. And this technique mainly to analyze and then finding the root cause, right? This is the major step, right? See, without understanding the root cause, the DMAC or the Lean Six Sigma will not move on, right? We'll call it as Y equal to F of X. Okay, X is the cause and Y is the output. Income is X, input is X, and then output is Y. So Y is F of X, you will hear frequently in this course. And a lot of statistical measurement tool and then analytical tool get used here. It's not about the voice of the people, right? It's everything is a data based, right? How we are going to derive it, everything based on the data. And measuring phase, so we have the statistical and probability and mean, median, mode, variance, standard deviation. These are all the terms it seems to new to you, but these are all very important in the Lean Six Sigma. And probability distribution, okay, normal distribution, binomial, and then Poisson, and the graphical analysis, histogram, box plot, okay, all these things will be get used in measure phase. And coming to analysis or analyze phase, there is a hypothesis testing. Okay, these are all the detailed analysis we are going to do. In this green belt, we will touch upon what are all the tools here and what is related to our RCM. We'll go in depth. Others we will touch it. When you go to the black belt, you have to do all this testing, right? Hypothesis testing, everything you have to learn though, right? And to verify, validate the hypothesis testing, we have a different methodology how to do analysis and everything, right? Yeah. So here, the same thing, the statistical methodology, what I discussed. The second thing called DOE. Okay, this also very important. Design of experiments. See, when I have a statistical model based on the statistics, I'm coming to a conclusion. Okay, this can be done. In that, I cannot go and then directly create it, right? There is a design of experiment is going to give you how it is successful. Okay, how I'm going to do this when I do this input F of X. Okay, what is my output? Is it going to survive my or satisfy my customer requirement? That's what we'll call it as a design of experiment before we release the product or before we conclude what we are going to do. Okay, and here what are all the things we are going to use here? Okay, so if you consider SPC chart, which is very powerful chart, we'll call it as statistical process control. Especially in RCM, your statistical process control is going to give you the high visibility and it is going to drive you to the expected room. Okay, we are going to see that in a very detailed practical way. And control charts, and then monitor stability, and then identify the special causes for the problem, and then process capability studies. These are all some of the methods we are going to see. Everything we are talking only on the theoretical side, but you will learn on the practical Especially the SPC is my favorite. Okay, you will get it a lot of on the SPC and control charts. Okay, so what is our goal? By learning this, what I'm going to achieve? The goal of this course or this particular Lean Six Sigma is near perfect quality. That's what we are aiming at. Okay, is it related to quality? I am from operation. Why I should learn, right? If ask that question, is quality is owned by quality or operation? Quality should be the ownership of operation, not the quality team, right? Unless your team understand, okay, what is the quality, how I need to work on. Okay, that is very important. Okay, quality people are there to identify your error, there to mark you, say that this is not going good. But here, say, as per my understanding or as per my review on this many experiences, the quality should be owned by the operation, not by the quality people. Okay. So what I'm going to achieve here, reduce variation and minimize defects, shorten the cycle time. This is very important, right? When I build the claim, how quickly I'm going to get the money and improve yield, enhance customer satisfaction, boost the bottom line. It's nothing but your revenue, right? Variation and defects, quasi-perfect production process, and 3.4 defects metrics, COQ, process improvement, measurement of variations. This is what we are going to do. By all this mean, what I'm going to achieve is cost saving. See, when your project is coming with around 52% revenue, okay, when you talk about the P&L, right? When you're in the manager and above, they won't ask you to see that what is the claim quality, what your team did, right? They will talk more on the P&L side of it. So it is going to help you out on your cost savings and how it is going to make you as a competitive advantage among your team and among your different organization. And then net income improvement, and then the profit maximization and the project based value. Okay, these are all the major area which we are going to cover in this particular session. Okay, anyone has any question, we will look into. Good, 25 people. I think we are increasing our number. The next one. See, this is very important slide. Okay, so please look into this. The quality cost, right? What we are talking about, how the quality cost is going to happen for my organization. First one, quality will be spend a lot of time in reducing your pain points. What do you mean by pain points? It's a client escalation and it is not going out of your door, right? That pain points, they'll spend a lot of amount in pain points fixing. That is the escalation fixing or the problem fixing. That is our major thing. And second one, it is operational metrics. Okay, they will go on and check all the operational metrics. Is it everything is going good or not? Then third one, it is going to be the improvement on the financial side. This is a major quality cost here. When it is coming to the quality cost, external failure cost, right? See, for example, we will take a product. Okay, for example, I'm leasing one iron box to the market. When my iron box is not working properly, they are returning back saying that I have warranty for 1 year. You do the repair. So for doing that corrections, I have to spend my energy, my labor, and then my resources to handle that particular cost. Right? It is a warranty claim will be my additional cost and service cost. Customer returning the product, I don't like this, and customer complaint, product liability, lawsuits, and then loss save. These are all the problems when the customer use my product, right? And before the product is leave to the customer, there is a cost of labor, and then there is a material involved, and then material of rework, and then overtime. See, for example, I'm producing, and the quality team is coming and then saying that this is not good, this is not meeting our requirement, then I have to do it back, right? This is our internal failure cost. And what is the inspection cost? See, inspection of the process, I'm checking it, all the material is going in the right direction, and then testing the material for sample, test equipments, and then inspection labor costs, and then quality audit. These are all inspection costs. It is a pure quality cost, right? And the prevention costs, how I'm going to stop it. Planning and training, the training program, preventive maintenance, and then improving quality, improving poor quality. These are all the quality costs. We'll compare that with the RCM, right? See, for example, external failure cost. What it mean? Whenever I get any claim denied, it's not paid. That is my external failure, right? What I need to do, I have to rework, I have to check it, what happened to my claim. For example, they're asking for additional documentation. Everything is your external failure cost. What is your internal failure cost? See, for example, I'm doing a charge entry, right? For that, I have to put my cost for the labor. And second thing, when I prepare that charge entry, my quality team is coming and then it's saying that it's a total waste. It is not going to pass. And second thing, leave quality team, right? If it is rejected, I'm sending through my clearing house and it is getting rejected. That is my internal failure, right? I have to rework again. I have to put my extra people to work on it. I have to redo the same exercise and then send it. And the inspection cost, as we discussed, is a quality cost, right? And prevention cost. Okay, for example, I want to reduce my rejection. So what am my plan, right? I have to plan and training. I have to training the team, and then I have to get into the details of it, and then how I need to fix it. These are all your quality cost, right? And coming to the next one, it is what is a rolled throughput yield? See, for example, I am filing a claim. Okay, we'll take the AR scenario. Okay, so when I touch the claim is in process. Okay, that is my first touch. Is it going to resolve? Am I going to get the payment? No. If the claim will be still there only. Second time, when I touch the claim is denied for inclusive denial, right? So by inclusive denial, am I going to solve this? No. What I need to do, I have to send it to coding. This become three touches, right? When it is going to the coding team, what they will do, they will correct it. And then, for example, they are going to add a modifier and then they are going to refile the claim. After they refile the claim, I'm marking that as a corrected claim and then they are filing it. Then after that, if it is resolving within 30 days, it's fine. Otherwise, I have to call again and then check it. This will become 5 times, right? See, this is my RTY. How many times it's my roll is getting ball is getting rolled, right? We are calling that as a RTY. How to calculate this RTY? Especially this is very effective for the people who is managing the AR production, right? In the shop floor, right? So that is very important. You should know how to calculate this RTY. Okay, so how to know do this? We have a practical session. They'll give you the details how you will calculate your RTY. See, if you know that RTY, definitely it's going to improve, right? How many touches you are doing? We are asking about the touch to resolve, right? This RTY talks about that. And second one, here I had given some detail. I'll add it. You can go through and then check this. And RTY in the context of Six Sigma, this is method of quality focused on the results. Okay, low defects, which will move into a cost savings and competitive advantage. Okay, the Six Sigma mainly to improve your process. Okay, I don't want to touch my claim multiple times. And impact of the complexity. Okay, when the level of process complexity increases, okay, what is going to happen? How I'm going to make this into a simpler process to make my RTY can be improved. Okay, consequence of low RTY, decrease RTY subsequently lead to decline in the final outcome of the quality level. See, for example, I am doing multiple time touches. It's going to reduce your quality. Okay, this we are going to cover it now. Okay, so